I'm from MTech AI School of Computing, second year. So today I'll be presenting on hybrid cloud architecture for AI-driven big data analytics. So in today's digital economy, like data has become one of the most valuable assets of organization. Like every digital interactions, whether it is an online or a mobile application or any financial transaction or IoT sensors, everything generates data. So large organization generates a terabytes of data or even petabytes of data daily. So this data contains some valuable insights that can help organization to optimize operations, improve the customers experience and detect fault and make an intelligent decisions. So however the extracting the meaningful insights from the such large data sets requires sophisticated computing infrastructure and advanced analytical technologies. So this is where the big data platforms and cloud computing and AI are come together. So modern organizations are rely on hybrid cloud architecture, which combines on-premises infrastructure with cloud environments. And this approach allows the organization to process the massive data sets efficiently while maintaining the control over the sensitive information. So in this presentation, I'll be explaining some modern data platforms or that are built and technology that can power them. So before we start discussing like about the platforms, we must understand an important concept called data gravity. So data gravity refers to the phenomena where large data sets become increasingly difficult to move across the systems as they grow in size. So when the data set reaches the terabyte or a petabyte scale, transforming them across the networks becomes extremely expensive and time consuming. So for example, like moving a petabyte of data between the data centers may require a massive network bandwidth and may take hours or even days. So because of this challenge, modern architecture often focus on bringing the computational closer to the data, rather than repeatedly moving the data between the systems. So several major sources contribute to the rapid growth of data. First of all, like the IoT systems and the industry devices, they can generate a continuous telemetry data from manufacturing plants and energy systems and manufacturing, I mean, smart infrastructures. Secondly, we have enterprises software platforms such as like ERP systems and transaction processing system generates a large value and structured operational data. So, and the third, the mobile application and the online platforms generates a massive stream of user activity data. So, because of this constant data generation, organization must adopt a distributed computer architecture capable of processing a large scale data streams efficiently. So, now that we can understand the scale of the modern data generation, so the next question is how the organization is going to extract the insights from this data. So the traditional analysis system focused on descriptive analytics, which meant analyzing the historical data to understand um, past performance. For example, like the business might analyze the sales reports or operational metrics using on the dashboards. But however, the modern analytics platforms have evolved significantly. Like today, the organizations are like moving towards the intelligence, like where AI and not like machine learning models analyze the massive data sets to generate the predictions and automated insights. And machine learning algorithms can also detect patterns in data that are not easily visible to human analysis. For example, like for financial institutions, like use machine learning models to in order to detect the fraud transactions by analyzing the behavior of the patterns in real time. So another now so here another emerging concept is like agentic analysis. So in agentic analysis analytics systems like AI agents can automate the explore data sets and detect the anomalies and generate the insights without even requiring of human to explicitly give the queries to it. So a technology enabling this system is an core like systems like a technology which has been enabling the system is a vector database. So the traditional rational database stored structured data in this tables with rows and columns. So the vector database also stores embeddings, which are numerical representation of complex information such as text, images, documents. So these embeddings capture the semantic meaning of the data, and this allows the system to perform similarity search between the documents data and they can retrieve the information that is conceptually related to the query even if the exact word is do not match. So this capability is especially important in AI applications such as recommendation systems and information knowledge retrieval. So now the to support this advanced analytical capabilities, the organization built can build a modern data platforms using a layered architecture actually. So like each layer is the data and like each layer performs a specific role in order to process the whole data pipeline. So the first layer is the data ingestion layer where it captures the income data from the applications like sensors and external systems. Like here the technology such as like app Apache Kafka, Apache Pulsar is are widely used for this purpose. Like here the Apache Kafka is a distributed event streaming platform that allows the system to process the large volume of real data. So internally, Kafka organizes the data into structured structures called topics. So which are divided into partitions. So like each partitions can be processed independently across each machines. So now we have a distributed architecture that allows the Kafka to handle the millions of events, millions of partitions. Like it may take which has been uh, generated per second, making it ideal for real-time data pipelines. So after ingestion, the data moves to the storage layer, the model. So the storage architecture often uses the data lakes and lakehouse storage systems. Here, the data lakes allows the organization to store the raw data in its original formats, including the structured and semi-structured and unstructured data. So next is like processing layer where the distributed computing frameworks analyze the large data sets. So here the widely used technologies like Apache Spark. So the Spark is a distributed data processing engine where is designed for large scale data analytics. So instead of processing data on a single machine, the Spark divides the large data into small partitions and distribute them across the clusters of machines. So the each machine process a portion of data in parallel. So then they can combine all the results as one and concatenate so that it can use for analysis. So Spark allows us support in-memory computing, like meaning data can be stored in memory during the processing instead of repeatedly reading from the disk. So this significantly increase the processing speed. Then we have a processing layer, and where it has a AI and machine layer, where it predicts the model, analyze the data, which will be processed. Finally, we have a serving layer, and where it delivers the insights of the data which is being processed through the dashboards and APIs. Now, The two major architecture shape can shape the modern data platforms or data house architecture and the data mesh. So here the data house architecture combines the scalability of data lakes within the structured analytics capabilities of data warehouse. So in traditional systems, the organization maintains the separate data lakes for raw storage and data warehouse for analytics. So maintaining these two systems requires a complex data pipelines. So the lake house on technologies such as like Delta Lake and Apache Ios and Apache Henry solve this problem by adding a metadata layers on the top of the data. So this technology supports the features like ACE, CID, transactions and schema enforcement and version control. This allows the organization to perform a reliable analytics directly on the data storage. So another important concept here is like data mesh. It's in traditional architecture again we have a centralized data engineering that team has all the data pipelines. As the organization scale, this approach creates the data mesh decentralized this data ownership. So each domain team manages its own data sets as a data products while following the shared governance of policy. So this allows the organization to scale the data operation across the multiple types, not relying on single tool. So the modern analytic platforms rely heavily on cloud computing infrastructure. So cloud platforms or provide several capabilities that are essential for large-scale analytics. One important capability is elastic computing. So this elastic computing allows the organization to dynamically scale the computing process depending on the workload demand. So for example, during the heavy workloads, additional computing nodes can be automatically provisioned. So another key capability is like uh, object storage systems such as like Amazon S3 and Azure Blob Storage. So these storage systems allow the organization to store the massive data sets so at really low cost. Cloud providers also offered a GPU accelerated computing infrastructure where the GPUs are like particularly important for machine learning workloads because they can perform thousands of mathematical operations in parallel. So this makes them ideal for training the deep learning models such as neural networks and then running it in order to have a proper insight and prediction on the data. So another emerging innovation is like confidential computing. So this confidential computing ensures that the data remains encrypted even when it's being processed. So this allows the organization to process sensitive data securely in the cloud environment. Now, although the cloud computing providers may have a lot of advantages, many organizations cannot move all their data to the cloud. So this may be the due to the data privacy regulation, security, and latency requirements. So here comes the hybrid cloud architecture to address the challenges by combining the multiple computing environments. So in hybrid architecture, some data sets remain stored in on-premises. So while analytics workload runs in the cloud platforms. So this allows the organization to maintain the control over the sensitive data while still benefiting the scalability of the cloud computing. So the hybrid architecture are widely used in industries such as like banking, in healthcare, telecommunication, etc. So now that we understand that infrastructure, we can examine how the data workflows through the modern analytical pipelines. So these pipelines begin with the event-driven ingestion. So where the systems capture the real-time data events. So the data is then processed using the distributed computing framework such as like Apache Spark. So after processing the machine learning, after processing the machine learning models, analyze the data to detect the patterns and generate the predictions. And advanced systems also uses the vector search systems and knowledge graphs. So knowledge graphs represent the relationship between the entities such as like customers, products, and transactions. This allows the system to understand the complex relationship between the data sets. So finally, we get the insights that are being delivered to the decision system, so that it can be used can be used as a support the business operations. Now, managing a large-scale distributed system can be also an extremely complex one. To simplify the deployment and scaling the modern platform, we can use containerization technology. So this containers package application together with dependency, allowing them to run consistently across any environments. So platforms such as Kubernetes manages this containerization workload. Kubernetes automatically handles the tasks such as like scheduling workloads across machines, like and scaling the resources based on the demand and recovering from the failures. So if one machine fails, the Kubernetes can automatically move the workload to another machine. This ensures that large analytics systems remain reliable, and containerization architecture. So the containerization architecture also enables the microservice-based analytical pipelines where the different service performs a specialized task. So with this technology in place, the organization can build powerful analytics systems across the multiple industries. So in a financial sector, machine learning models can analyze the transaction terms streams to detect the fraud in the real time. In healthcare, the large biomedical datasets are being analyzed to support the personalized medicine and predictive diagnostics. And in retail, the recommendation analysis used for customer not to read the customer behavior to generate the personalized product suggestion. And in telecommunication, the predictive maintenance model like analyzes the network performance data in order to detect the potential failures before they occur. So this application demonstrates how the modern data platform deliver a significant economical value to the businesses. Though, despite their advantages, the modern data platform introduce their own challenges, like managing the distributed infrastructure across the hybrid environments can be complex. And then organizations that must ensure the strong security, access control, regulatory compliance. That is also one of the challenges. So another challenge is like scaling the machine learning model workload efficiently while maintaining the low latency analytics. It's on another challenge. So to address all those challenges, organizations are relying on the monitoring systems, orchestration platforms, and governance frameworks. So looking ahead, like several trends are like shaping the future big data analytics. So one major trend is like development of AI native data platforms where the machine learning capabilities are integrated directly into the data infrastructure. Another trend is like real-time streaming analytics where like enabling the organization to analyze the data continuously. And vector databases will play an increasingly important role in AI-driven systems, and edge computing will also become more important by just enabling the data processing closer to the data sources. So together, these innovations will transform the data platform into an intelligent decision infrastructure so capable of supporting real-time analytics and automated decision system. So thank you very much for the opportunity. I will be thank you very much once again.